Hi, everyone. Welcome to our session, Creating Cattle, Not Pets, or using AWS CloudFormation to build code and infrastructure. Our speaker today is Barbara Hoy. Barbara is a backend software developer in the Publishing, Archives, and Digitization group at the California Digital Library at the University of California Office of the President, where she has worked since 2011. She has a PhD in comparative literature from UCLA and loves working on projects and services that are used by librarians, students, and researchers throughout the UC system and beyond. We will be taking questions throughout the presentation, so just raise your hand and we'll get a mic to you so those on Zoom can also hear the question. And I'll also be taking questions in the virtual chat Q&A. So welcome, Barbara.
Hi, everyone. Good to see you. I think, as Marissa said, I'm open to taking questions throughout the presentation. It's not super long, so there's plenty of time if you have anything you want to say or ask. So my presentation is about this notion of cattle versus pets. I don't know if anybody has heard this analogy. Yes, a couple of you. Let's see. Yes. So I don't, what is CloudFormation? This is the first question. So at the core, you write templates that define the creation of AWS resources. So for instance, EC2 instances, code build projects, security groups, load balancers, you name it. AWS has a gajillion services that you can create. And then you write it as a YAML template, or as a JSON file. And then, so you will then run CloudFormation create stack to build the stack. So this is either a command line interface command, or you can run it through, for example, Boto 3 in Python. There are a number of ways that you can run the creation of the stack. And so the idea is to build up and tear down these stacks easily using the CloudFormation commands. So if you need to make a change, you tear down the existing stack and build a new one. So in other words, you're creating cattle, not pets. It's not a very vegan idea, but there we have it. That's what the idea that's out there. And there are many tools that exist for creating and managing the templates. For example, there's a tool called Sceptre that I'll get into a little bit later that will help you manage these things. And there's tools such as Troposphere, which allows you to write the templates using a Python library instead of actually having to write YAML or JSON. So in my case, just to give you an idea of what you might want to build, this is a project that we had that we need to build this infrastructure. So you can see that there's within a virtual private cloud. I don't know what people's familiarity with AWS is, but basically AWS has this concept of a virtual private cloud, so you can have all your resources within this private network. And so we needed to have a Redis cache, an Elasticsearch instance, a Postgres instance, and all three of those then are built within using AWS services. So the Redis cache is AWS Elastic Cache. Elasticsearch is actually an OpenSearch instance, and Postgres is an RDS instance. And then we have our actual application instances. So these consist of a server with a Docker container, Tomcat running as well, also Apache. And this is on EC2, Amazon Linux 2 box. So the idea is that you could have a couple of nodes, you could have 100 nodes, that these would all be identical. And so these would be your cattle. And then we have a load balancer with a reverse proxy. So this is an AWS application load balancer. And then in front of that, we have an elastic IP pointing to, for example, the stage site. And then we also have binary file storage in S3. So you can see that there are a whole bunch of different components, resources that need to be created. And of course, you could do that using click ops, but it's not very replicable. And also CloudFormation is sort of the way to do things. And I think it does make sense. There's a reason why. So I'll get into this a little bit. Are there any questions so far? So the way that I went about doing this is to use yet another AWS service called code build. And what you do in code build is you create a YAML file that defines a code build project. And this YAML file, then what you do, what the steps that happen as defined by this YAML file are to build the Docker image based on a Docker file and to push this to Amazon or AWS ECR, the Elastic Container Registry, which is sort of like Amazon's Docker hub. So here is just, I'm sure you cannot see this, especially if you're in the room, but this is kind of what a build spec.yaml looks like. So you have some pre-build commands and build commands and post-build commands, and it's written in YAML. It's fairly straightforward. There's definitely as always, some gotchas in terms of passing in variables. Yeah, any questions on that? Okay. And then once you have the code build project defined, then we create the code build project using CloudFormation. So in the CloudFormation template, which then will refer to this code build that I just talked about, you also create an IAM role and policy, which will allow you to have permissions that you need to do all this. We create a personal access token for authenticating to GitHub, so to the code, and implement a GitHub webhook. And this triggers a new code build project build, which is what I just talked about, every time code is pushed to the GitHub repo. And you define this source code and what's called a build spec.yaml. So here is a little preview of this. It's actually a Troposphere script that creates the CloudFormation template. And this little highlighted in yellow is where you're defining a trigger to fire a build, so a code build, whenever new code is pushed to GitHub. So basically, you have a nice little pipeline going there. And this also took a little bit of setup on GitHub. Also, you have to define a webhook. All right, and then we create, finally, the infrastructure stack using CloudFormation. And so in the templates, there are several templates, and we define all the components of the Nuxio stack, including, as you remember from our infrastructure diagram earlier, the EC2 instances, the application load balancer, and also the security groups. So there's moving on. So one other consideration is when you're building different environments. So for example, stage versus prod, how do you want to be able to use the same template essentially and have different inputs, say different IP addresses and so forth for stage versus prod, or different permissions, what have you. So CloudFormation allows for the use of a JSON file, and this contains input parameters into the CloudFormation template. And so what I had done at first is to use configuration files and then run a script to convert those into JSON. But then I also came across a tool named Sceptre, which we're using quite a bit at CDL. And I'm in the process of shifting to that to manage templates. So what Sceptre is, it's a tool for managing CloudFormation stacks. You can read more about it at this URL, docs.sceptre-project.org. And what it does is it allows you to manage template configuration. So if you have multiple parameters that you need to input according to different environments, it will let you set that up neatly. It provides you with commands to run, update, and delete stacks, and also allows you to provide the output of one stack to another. And you can also use it in conjunction with Troposphere or any other tools that allow you to create templates. And surprisingly, well, maybe not so surprisingly, AWS does not actually provide very good tools for doing this themselves. You can sort of put together things using Bodo and so forth, but it really doesn't allow you to neatly do, especially the configuration and the output of one stack to another. It really doesn't provide tools and those tools, but Sceptre is really pretty great when it comes to that. And also, I've liked Troposphere. Whoops. So I have liked Troposphere because I'm familiar with Python. I'm not so familiar with YAML, and writing things in JSON can be a pain. So for more complex templates, I've used Troposphere to write them in Python. You could also argue that it's just adding a layer of complication and tooling, and so you might want to just write them from scratch. Definitely, I know people who prefer to do that. I think Sceptre, however, seems to me to be a total win in any situation, unless you're just, writing a very quick test or learning CloudFormation. Then I would say just write the template and run it using a command line tool. All right. So the thing with something like Nuxio is that you need to be aware that the application you're working with, you need to be aware of whether the application that you're working with is architected for this cattle model or not. So for example, Nuxio, which I mentioned, which is a digital asset management system, and it's written in Java, and it's sort of, I don't know, it's an older application, and they tout it as, oh, you can run it in the cloud and you can run it, have multiple nodes running, but actually it doesn't lend itself to this model because it requires sticky sessions, which is fine for web clients. You can get around that, but when it comes to programmatic API calls, it is a problem because you're hitting the same machine over and over. It wants to hit the same machine over and over, so it's sort of not acting in this replicable cattle way. And the application also wants each node in the cluster to have a unique ID. So if each node in the cluster has a unique ID, by definition, it's a pet. So pets resist cloning. Really, cattles need to be, in the sense of the application, they should be generic and stateless. And because of all this, sadly, at the moment, our Nuxio application is one pretty cow sitting behind a load balancer, which really is not the point of this whole setup. So really, we could do some shenanigans to create one special EC2 instance will handle API calls, and then have a cluster of other ones that are for the web API calls. But since the application is not architected for that in the first place, it really would require a lot of work to do this. And I mean, overall, I'm still finding it a huge win that I can reclone this clone over and over again. And if I make little tweaks, then it's easy to replicate in, say, stage versus prod, or, even if I wanted dev. So I don't think it was a worthless exercise, and certainly we can use this. We are using this approach basically in all the software that we are running, but this is kind of a problem that it's hard to get around. So I think it's really worth looking at your applications prior in these ways prior to setting them up to see if they can actually take full advantage of this model. So stuff that I'm still working on this is a little getting into the nitty-gritty, but so whenever you register, you create new EC2 instances, they need to be registered to the load balancer target group. So that's in AWS speak. You have your fleet of instances that are within this load balancer group so that you can switch between the instances and spin up new ones if they fail. And so right now, if in the template, you create new instances, there's no automated way to add those to the load balancer group. So that's a little script to write. Also just automating the code pipeline fully. So CI/CD pipeline, and then also testing, automated integration and regression testing. And also this less manual workflow for deploying to production once stage is a known good. So this is quite a bit more work, but we're on the way there. And we've kind of gotten to this stage with several of our applications. And that's it. It's a pretty short and sweet presentation. I don't know if anybody has questions. Here's my email if you have any questions that occur after.
Thank you. My name is Gary. I'm a Ruby developer at UC Irvine. And my question, well, I have two questions if we have time, but the first one is what did everything look like before you started this transition to AWS? Because that's kind of where we are now, where we have a very similar architecture actually to you, where we have 2 production servers, 2 staging servers, and very similar actually what you showed, minus the AWS components, right? Everything for us is all UCI hosted, UCI everything. Mm-hmm. What does that transition look like? And do you have any advice? And I guess like was there a transition that you were there for?
Oh, yes, there was definitely a transition. It's work. I mean, especially if you haven't done it before, right? I think once you've done it once, then it becomes a lot easier. But yeah, really it required, what it looked like before is that there was one application server still sitting behind, and it was sitting behind another EC2 box that had been configured as with reverse proxy, an Apache reverse proxy on it. And then there were the Redis, Elasticsearch, and Postgres. Those existed, but it was all configured, sort of once on that one machine or those 2 machines. And it wasn't really documented. So it really required, and the person who had set it up was retiring, and it was kind of like all in his head. So I think it required a lot of digging in and kind of figuring out what was going on and translating that into this replicable state. So yes, it was work. It took a lot of time.
And Gary, I would add to that also at CDL, we have other programs where we used Puppet to manage our services, our resources. And so we did have some way to just bring up an EC2 server and use Puppet to define everything. And as we move some of our services into AWS, we use that knowledge that's already captured within Puppet to help us kind of transition. But we're still using this CloudFormation template model and getting our services on board. So I have a couple of questions from the virtual audience. So are there any plans on switching to Terraform?
No, I don't think so. I think that, I think the tools that I mentioned kind of do the job of what Terraform would do. And we don't have any expertise in Terraform. It definitely comes up, but I don't think that's the general trajectory. Yeah.
And also, was there a reason why AWS was chosen over other cloud platforms?
That's a good question. So at CDL, we pretty much have bought into AWS. We have a contract, and we have a central AI. What does the AIS stand for, Colin?
IAS.
Yeah, so we have a sort of basically a group of sysadmins in-house that Colin is one of here. And they also have migrated everything into AWS. So we're really kind of bought in. That's the answer.
So you bought in when you had this contract, but what were some of the thoughts when you were deciding to make that contract over somebody like, Google Cloud or some of the other competitors?
That's an excellent question. I don't know if Marissa or Colin have more.
I would say that it was happening at a broader level. CDL is part of the UCOP underneath that umbrella, and we were all going off of our data centers that we were using with UCOP, and so they were starting to move to AWS, and so we decided to jump on board with that. So yes, align. But we are separate accounts from UCOP. We're what they call as unmanaged accounts. We manage our own accounts, but we still get to take advantage of the UCOP contract.
Well, thank you very much. Really interesting project. I'm curious about the sort of sustainability and financial decisions here. It seems like because you've got a legacy application that's really not designed for a cloud environment, there's not really any way to scale this automatically from what you're saying. You got to basically go in and rebuild it, if I understand you correctly. If you needed to resize it was too slow. The economics of the cloud work really, really well when you can ramp things up and ramp things down in an automated way. And you obviously can't do that here. So there's a lot of value to this project. Just from what you've learned, it's very obvious, which is great to move it to AWS. But I'm curious whether you think it's for this particular application, whether it's economic to run it as a cloud app when you're essentially running a legacy application that you kind of build it. And since I guess you could turn it off and turn it on, that's about the only way you could save money. But I'm just curious what your analysis is. Maybe it's just not that expensive anyway, but I know a lot of people struggle with, if you can make it a really elastic application, it makes a lot of sense in the cloud. Whereas if it's a more static like this, the economics are more questionable versus just running it on some kind of hosted architecture that you might have in-house. So I'm just curious what your thoughts were on this, and whether you have any concerns about, is it going to cost you a lot more to operate in this environment than it did before?
I might hand that question to Colin, but we don't have any in-house servers anymore, so that it's not an option. Yeah. I don't know if Colin has anything to add to that.
So my name's Colin. I work for CDL now. I used to work for the team at UCOP that provided their VMware infrastructure and was part of the reason for them moving to AWS. We had layers and layers of bureaucracy, and our VMware infrastructure really paralyzed us in a lot of ways. And so part of the reason CDL moved to AWS is so that they would have flexibility. So they just moved their entire architecture across the board, every application into AWS in a lift and shift way, and just got the heck out of our VMware environment. So that's why it moved to AWS in the first place. I think the reason for doing things in this CloudFormation scepterized troposphere way is basically for, repeatability, flexibility, migrations, that kind of thing. If you have your infrastructure as code, it's a lot easier to understand it and to move it later. As for the question earlier about, what was it? What's the other
Cost?
infrastructure as code thing that we're not using? Terraform.
Oh, Terraform.
Yeah. We made a decision to go with Sceptre over Terraform mainly because we're an AWS only shop. So we don't need the multi-cloud capabilities that Terraform gets you. We're starting to revisit that decision. We are still only an AWS shop and have no intention of going into Google or Azure. But it is clear that if you want to collaborate with other people, most of them are writing Terraform code. So you better be able to read their Terraform code. So having familiarity with Terraform is a good thing. Our main problem with Terraform is that you have to put that state file somewhere. If you're going to be working together on the same stacks, you need to be using the same state file. So whether that's an S3 bucket, where that S3 bucket should go, whether you pay HashiCorp to use their hosted service, we just didn't want to deal with any of that. We just wanted to rely on CloudFormation. It's already there. It's in whatever account you're working in, and we don't have to worry about it.
Hi, I'm Brandon. I'm a Rails and front-end developer. So in your architecture, is it, so we're talking about, I would say, treating your infrastructure as precious or not. Like your database is often going to be, that's, the information that you need to persist your source of truth or whatever. Is there a way in the system that you're talking about to basically make a division between those resources that are precious and are not, that need to persist between builds and those kinds of things? Does that make sense?
Yeah,
Okay.
it does. CloudFormation definitely has you can set configuration that will say you're not allowed to tear it down, put restrictions on what can be torn down by whom. So that's one way to protect it. You can also, they recommend that you also use change sets, basically whenever you would restrict your updates or your teardowns to any piece of infrastructure, so that you create a change set that says, hey, this is what's going to change. And are you okay with that before you make the change or tear it down? So yeah, I think by default, things are just like, yeah, tear it up, pull it down. But for example, like an RDS instance or OpenSearch, you wouldn't want to do that, right? Unless you want backups and you want persistence. So does that answer your question? Okay.
Hey, Barbara, thank you so much for that presentation. My question is a little bit general and going back to the point that, Colin, you were making earlier. So I'm from Riverside, I work in research computing, and we have a hybrid cloud strategy. So we work with multiple cloud providers, and we are really exploring using Terraform blueprints for building research templates that our researchers can use. But have you come across any way within the UC system where these kinds of templates can be shared across systems and campuses? Because I can see that something that you might be successful with in UCOP might come in handy to the Riverside library team as well. So are there any resources where we can create these kinds of blueprints and share with each other and see if we can use them?
Yeah, that's a really excellent question. I personally don't know of anything that's system-wide like that. I know that even within CDL, we sometimes have a hard time sharing things between different groups. I think within CDL, really, GitHub is the place that happens. I know that the difficult thing with this kind of infrastructure and these CloudFormation templates is that sometimes you want to be really careful about your sensitive information. And so I think people, even though I don't think that there's anything publicly sensitive in this repo, just kind of out of an abundance of caution, it's in a private repo. So, but I do see your point and like it that it would be good to be sharing more. Yeah. Yeah.
I'm Rhett with UCI School of Education, full stack JavaScript developer. I've been working with Elastic Beanstalk, which is very similar to this, but the significant difference is that you have infrastructure as code and can tweak that infrastructure, and I'm limited in this little tiny subset. Good thing is it does all of these things, a lot of these things without a lot of the extra learning. And I'm kind of struggling right now with the minor headaches of being locked into this particular subset. So the question that I have is, did you try Elastic Beanstalk at all? And do you have any advice for making that sudden jump from the being jailed to infrastructure as code?
I did try Elastic Beanstalk with this stack, and I think partly because of its kind of older, the way it was configured, I was like, you know what, I need more control over how to configure these machines, and so that's why I ended up giving up on Elastic Beanstalk actually, and building these EC2 instances more sort of from scratch. But you can actually use CloudFormation to build Elastic Beanstalk instances in a replicable way. That's totally possible. We definitely have things that are running in Elastic Beanstalk, and then we're trying to move towards creating those using CloudFormation. Does that answer your question? Or
A little. It sounds like one of the possibilities is to transition to the CloudFormation Beanstalk and then potentially just CloudFormation.
yeah, so the question was, it sounds like it's possible to transition to using CloudFormation with Beanstalk. And yeah, so you kind of, it sounds like you're creating your Elastic Beanstalk now like through ClickOps or something. CLI. So instead you would use CloudFormation to automate those the clicks essentially.
A question here. Do you foresee AI and cloud helping you work in any way, or has it been deployed already?
AI and cloud?
Yeah, maybe like with CodePilot, generating your code for CloudFormation templates. Perhaps?
Oh, I would know. We've kind of like played a little bit with that. My colleague Amy has definitely, toyed with that, but we haven't in any serious way. I mean, she's using. You can, there's definitely code editors that have AI built into them, but yeah, I still need human intervention.
Dana from Irvine. And actually, yeah, I have used CodePilot to help with some of these things. And kind of amusingly, the AWS CodePilot made lots of mistakes with implementing the AWS stuff. And I was like, this is the one thing I think you should know. The other thing I was going to say, though, is one thing I like about CloudFormation kind of over Terraform is the drift feature, which is this thing that you can basically say, show me what someone may have manually changed away from what you want there. Because I'm kind of horrible at going in and being like, oh, I just need to adjust this one thing, and I don't want to go through the whole build process yet. And then I forget about it, and I'm like, wait, what did I do last week or yesterday that I needed to actually go and put back into the code? And I think that drift feature is pretty neat. It's like, okay, these are the things that are slightly off from what you expect to be there. And that can be like an automated report that gets sent to you when you it's like, hey, it's drifted. You should do something about that.
Yeah, the one thing with that is that it doesn't detect drift sort of like within the EC2 instance. But yeah, I meant to mention that and forgot. Thank you.
So on the subject of drift detection, we found that it's not reliable enough. There were just random little things like it didn't recognize tags in the CloudFormation output. And so it would say that the stack had drifted when it really hadn't. It didn't, the way the EFS volume was represented in the JSON didn't show up in CloudFormation's drift detection. So we just got so tired of seeing that kind of stuff that we turned off the config rule requiring the drift detection and alerting us on it. As for Beanstalk, I think if you go to your console and click on CloudFormation, you may see CloudFormation stacks underneath your Beanstalk stacks. So you might check those out and see if they give you any hints for how to do it in pure CloudFormation.
Has this altered the way you do your dev environments in any way? Has this improved, like maybe the confidence you have that your dev environment matches your staging and production environments? Or is there any, have you noticed any difference in that aspect? Because that was one of the reasons that we were probably more to do Dockerizing than AWS, but that was one of the reasons that we were really looking into containerizing and putting on AWS. All of our stuff is have better confidence that our dev environments match our production environments, because I'm sick of SSHing into production.
Yeah, that's a really great question. In this particular instance that I was talking about, we're actually dealing, it's a third-party piece of software, and so we're not actually concerned about, you know, versioning in quite that sense if you're doing in-house development. But we are currently working on a project where we're doing in-house development and have decided to use a Docker container because we're actually using Airflow. So yeah, we are planning on, we're in the process actually of using Sceptre and CloudFormation to set up that so that we make sure that we're running the same environment in DevStage and production. And it does give you a lot more confidence. Yes.
Thank you. Also, thank you for the talk. It was really, really good.
Oh, you're welcome. Thank you. Any other questions?
I just wanted to ask, the application, is that a in-house built custom application that you've deployed?
So the one that I described in this presentation is not. It's a third-party Java app, but but we are developing in-house.
Okay, because I kind of want to continue the conversation in terms of like lessons learned in terms of application development towards basically the idea of how, you know, best practices of writing applications so that you don't encounter this issue when you decide to deploy to a cloud infrastructure and treating, you know, like avoiding the sticky sessions and those kinds of things. Yeah, there's potential there. So
yeah, it's a different paradigm, right, than I think historically we've been used to. So yeah, you want to think about, well, I think a big thing is just this principle that each instance of your application should well and truly be stateless. And, you know, if the sessions are sticky or it needs to have a unique ID, then you've broken that model.
I was just going to mention for everyone else, basically the idea of looking up the 12-factor app principles that Heroku put out applied to this kind of concept pretty well. So 12-factor app.
Yeah, I'll just add to that, the 12factor.net, I believe is what you can refer to. And it's fine. And we use that also within our program to help us guide us with those best practices, because it has a lot of this information in here. And also our group together, we have information sharing sessions weekly to share out the development that we're doing and the problems we're running into. And so it's been really helpful to share that knowledge out amongst our group.
Okay, looks like there are no more questions. Going once, going twice. Thank you so much for coming to my talk. And please email if you have any questions. I would love to talk. nerd out about this stuff, and I'm on the UC Tech Slack also.